Welcome back to Algebra 1 with Miss Betsy. Today we are going to be discussing how we multiply and divide rational numbers. If you are one of those who've been tracking along with me in your own textbook, I am using the second edition of Algebra 1 for Christian Schools. It's published by Bob Jones University Press. If you have the third edition, the sections are not compatible, so you are going to need to flip around in your book and see where you're at. Or you don't even have to have a book. You can still learn how to multiply rational expressions simply by watching this video and working along with me. Let's go ahead and pray, and then we'll get started. Father, I thank you that you love us, and I thank you for reminders today of how you know us intimately, and you will speak through those people that you place in our lives to give us a reminder of just how personal you are to us. Father, I ask that you would help us to have our ears attuned to you today, and that we would be diligent to study those things that you put before us. I pray in the name of Jesus, amen. All right, my lame joke for the day. Why is it that the banana put on sunscreen before he went to the beach? Well, he was afraid that if he didn't do that, he would peel. Section 2.3, multiplying and dividing rational numbers, and it is still allergy season here in Texas, and I can just feel the sneezing coming on, so bear with me. We are on page 56. Now let's think about this. How are you going to multiply fractions together? And this should be a review for every single one of you. If you had 2/3 times 5/7, what would you do? Well, you have 2/3 times 5/7. And you learned that in order to multiply fractions together, you multiply numerators together, and the numerators are the numbers in the top of this fraction, and you divide it by the product of the denominators. When you multiply two or more factors together, you get a product. So we have 2 times 5, 3 times 7 in the denominator. Therefore, the product of the two fractions, 2/3 and 5/7, is yet another fraction, which is 10/21. And these are what we call rational expressions. Rational numbers are numbers that can be written with a numerator, with a denominator, but that denominator cannot be equal to 0. It has to be different from 0 because in our mathematical system, division by 0 is undefined. There's just no way to do it. So you should know already how to multiply rational numbers together. Now, we learned something in our last video, a definition or an algebraic description of something that we called, that was strange, of something that we called the fundamental principle of fractions. If you haven't learned this yet, you need to make sure that you can tell anyone who asks you in a math sense, what is the fundamental principle of fractions? And in the language of algebra, this is what it says. If A, no comma there, if A, B, and C are real numbers, and B as well as C are different from 0, neither B nor C can be equal to 0, then if you have A over B, that's the same as A times C divided by B times C, and that's what lets us rewrite fractions with a common denominator. It's what lets us reduce a fraction to lowest terms. For example, if we wanted to reduce 4/10 to lowest terms, you know that that fraction is not reduced because both the numerator and the denominator are divisible by 0. So we can change 4 into this is slightly different from our illustration here. We can change this into 2 times 2 over 2 times 5. See, we have our same numerator here. I mean, our same number in the numerator as we do in the denominator. So 4/10 is equal to 2/5. So that is how we are able to reduce fractions. You can also, I'm really having a brain freeze here. I think part of it is because I'm trying to go back and reteach the last lesson. So I'm going to pause. Short on time, I'm not going to start this over. We're just going to leave this right here, fundamental principle of fractions. This allows us to reduce. It also allows us to find a common denominator. Common denominator is what we use with addition and subtraction, but we're not going to focus on that today. And I apologize for that brain freeze. I'm going to blame it on the fact that even though it's the end of September almost, it's still summertime here in Texas, and my allergies are driving me crazy. Let's go ahead and look at another example that I want to show you of multiplying fractions together. It's 2/3 times 3, what do I want us to, 2/3 times 3/5. Two different ways we can approach this problem. We just illustrated that you can multiply the numerators, you can multiply the denominators, and then we end up with 6/15. But fractions, or rationals, must always be expressed in lowest terms. Always. Lowest terms means that there are no factors common to the numerator and common to the denominator. Well, we've got a problem here. If we were to prime factor the 6, well, we're going to be right back to what we had here. Prime factor the 15, and we have 3 times 5. Do we have any factors in common here? Yes, we do. So we can cancel those common factors, and we now have a 2 in the numerator, and a 2, and a 5 in the denominator. So the reduced form, in lowest terms, of our answer, 6/15, is 2/5. What we did here was we multiplied numerators and denominators, got a fraction that needs to be reduced, prime factored it, and canceled common factors. So you may cancel after multiplying, or you may cancel before multiplying. When I say cancel, we're canceling common factors, the same number in the numerator, same factor in the numerator, the same factor in the denominator, and we can do that because any number divided by itself is equal to 1, and 1 times any number doesn't change the value of that number. And we learned that with our multiplicative property of equality that tells us exactly that. If you take a number and multiply it by 1, you don't change that number at all. Now, let's take the same problem and see if we can cancel before we multiply and what will happen. We have 2/3 times 3/5. I look at this and I notice that I have a factor of 3 in the denominator and a factor of 3 in the numerator, and then I am therefore able to cancel those factors. The only factors I have remaining are 2 and 5. So the product of 2/3 and 3/5 is 2/5. Now you look at this and there's just not a whole huge amount of difference there, is there? But let me illustrate something for you. we're going to cancel after multiplying and before multiplying again and see what we end up with. I have 43 over 31 times 31 over 74. Okay, now we're going under the true operation, the true procedure in algebra that if we're going to, in math and arithmetic, that if we're going to multiply fractions, we're going to multiply the numerators together, and we're going to multiply the denominators together. Now I'm not going to hand multiply 43 times 31, but that gives us 1,333, and 31 times 74 gives us 2,294. My eyes are already glazing over because I don't particularly care to do long multiplication or long division by hand. Now we're thinking, you know what, there's got to be some sort of common factor. That really can't be lowest terms. So we're going to now prime factor, and by the time we come up with prime numbers that are factors here, we end up with 31 times 43. Both of these are prime numbers. When we factor this, 2,294, we know there's going to be a factor of 2 in it because it's even, and we end up with 2 times 31 times 37. All right? Now we say, okay, I multiplied together, I have my product, I factored it, let me cancel common factors. The only factors that we have in common here are the prime number 31. So our product is 43 over 2 times 37, which is 74. Now, I don't know about you, I didn't like that. And on a bad day, I'd probably do something wrong with my math because I'd be so bored with it or I'd be in such a hurry that I would mismultiply. Now, however, if we cancel before multiplying and we recognize that we have a 31 in the denominator, a 31 in the numerator, and let's just think, 74 is even. What's 74? Divided by 2. 2 times 37. We're just thinking this. Nothing that we can do with that. With the 43, which is a prime number. Look at how much more quickly we have arrived at exactly the same answer as we did by going through this long obnoxious mess over here. And it really wasn't obnoxious the way I did it because I just wrote down the answers. I didn't do the multiplication out, and I didn't go through all of the headache to figure out that, okay, I got to keep going, I can't divide it by 2 or by 3 or by 5 or 7 or 11 or 13 or 17, 19, 23, 29. Oh, good grief, what is the next prime number after 29? It's 31. So, the moral of this story is, the moral of this illustration here is cancel common factors first if at all possible. Cancel common factors before multiplying. Your life will be much easier. Moms and dads, you will have far less drama to deal with. You will hear less, fewer pages being torn out and crumbled and pens being thrown across the room because kids are frustrated. If you can cancel common factors first, your life is much easier. And I have lost the lid to my marker. Here it is on the floor. In your text, it gives us a methodology for multiplying rationals together. Let me give you the abbreviation of what they say. I'm not going to write out all of the words. I'll use some abbreviations, but you can listen to me as I talk, particularly if you don't have the same text that I have. And then you can have a little recipe to follow when you want to multiply rationals. First, you're going to want to factor both the numerator and the denominator into prime numbers so that you have the prime factorization of both the numerator and the denominator. Then you're going to look at the numerator and the denominator, and you're going to cancel all pairs of factors, numerator to denominator. So you're going to cancel whenever it's possible. And then finally, this is like a no-brainer, you're going to have product over product. What that means is if you have 2 times 3 over 7 times 11, that's not your answer, is it? You have to go ahead and multiply everything out so that you have 6 over 77. That right there is the reduced form of some fraction. You know, it could have been 12 154ths. This is the reduced form. So this is what you do to multiply rationals. Much, much, much easier. You leave yourself far less open to mistakes. You save yourself time and frustration if you factor into primes and cancel before you multiply the fractions or the rational expressions together. Let me go ahead and do example 2 and example 3 from your book. These are probably really fairly redundant for you if you're tracking along pretty well with what you're doing, and if you're still having difficulty, these will be good for you. Example 2 is 3/4 times 18/7. 3/4 times 18 over 7, and this is example number 2. What we want to do is write each number as a product of primes. 3 over 2 times 2 times, how does 18 prime factor? What's 2 times 3 squared, because we have 2 times 9, 3 times 3. That's one way that we can come up with the prime factorization of 18. Another way would be that you saw, oh, 18 is 6 times 3, that's a 3. So you have 6 is 2 times 3. We have another 3. And you see that even though we used 2 different factors to begin with, the prime factorization is the same, which is 2 times 3 squared. And 7 is prime. Now, you notice that I indicated 3 squared here? I have 2 times 2 here. I could just as easily have said 2 squared. I could have just as easily have said 3 times 3. Use whichever form here works best for your mind. Now we're going to look for what common factors we have. 3's, well, there's a 3 there, but they're in the denominator. In order for factors to be common, one has to be in the numerator and one has to be in the denominator. And there are no 3's in the denominator. We have one factor of 2. That means this factor of 2 we can't touch because it doesn't have a pair. This one's already been used up, and we can't use that exponent because that exponent means that we're using 3 as a factor twice. And that's all we have left. 3 times 9 is 27. That doesn't look right. Okay, I was going to say 3 times 9 is 27 over 7. What did I forget to do? I have a factor of 2. 2 times 7 is 14. And that's the product of 3/4 and 18/7. Now let me go ahead and do example 3, 12 35ths, 42 27ths. 12 35ths, 42, 37ths. This is example 3 in your text, which is probably about page 61. Let me see, 12 35ths times 42 27ths. Did you catch what I was doing? I was looking back and forth and making sure I had solved the problem correctly. Needed to do that because we would have had a mess, because 37 is a prime number. What we're going to do now is write each of these numerators and denominators as a product of prime numbers. 12 is 2 squared times 3. I'm not teaching you how to do prime factors, I'm just giving it to you. 35 is 5 times 7. And I'll use 42 as an illustration. It's 2 times 3 times 7. 42, one way that you might begin that factorization is to say that 6 times 7 is equal to 42. Then we have 2 times 3. We now have the bottom of all of our branches is a prime number, so we have 2 times 3 times 7. But oh, Miss Betsy, I forgot that 6 times 7 is 42. But I know that I can divide it by 2. All right. 2 times 21, and then 21 factors into 3 times 7. So again, it doesn't matter what your initial pair of factors is. You're going to end up with the correct prime factorization. And then 27 is 3 times 9, which is 3 times 3 times 3, or 3 cubed. This, now we have the prime factorization of these numbers, and we're looking for pairs of factors that they share in common. There's a pair of 7s. They have 2's this way, but they don't count. They have to be numerator, denominator. So we have 3 factors of 3 here. We have 1. So that cancels, and instead of 3, we end up with 3 squared, or 2 factors of 3. All right? If you don't like that, back up the tape to where I have this written as 3 cubed, and instead I'll do 3 times 3 times 3. And that shows you that I've canceled. I have 1 pair of 3's, and I have 2 3's remaining in the denominator here. Now, I've got another 3 over there, don't I? Didn't catch that at first. Now, do I have any more common factors? 2 squared and 2. They're not common because they're both in the numerator. 5 and 3. That's all we have. A reduced form here of the product of these two rational numbers is 8 over 15. I think it's pretty straightforward. This should be review for all of you. I'm hoping that if it's been a while since you've done this, that it comes back to you really, really quickly. Now, if we want to divide rationals next, we've talked about inverse operations, or operations that undo one another. And we compare that to zipping a zipper up. You know, you've got your jacket on, you zip it up, then you unzip it and you're right back where you've started with. Addition and subtraction undo one another. Say I have $100 in my checking account. You give me $50, I have $150. You subtract $50, I'm back to $100. Addition and subtraction are inverse operations. They leave no net change on what you've begun with. I might have gone up to 150, but I came right back down to my initial, or to my original starting amount, which was $100. Well, just like addition and subtraction are inverse operations, multiplication and division are also inverse operations. And because they're inverses, we can divide rationals by multiplying by the reciprocal of the divisor. Divide rationals by multiplying by the reciprocal of the divisor. Reciprocal of the divisor. And what now are reciprocals? Well, reciprocals have another name, and that name is multiplicative inverse. So what is a reciprocal? Now, nope, the answer is not just to tell me that it's a multiplicative inverse. That's another name for it. Multiplicative. But without knowing what that vocabulary means, it's a meaningless definition. Reciprocals are two numbers whose product is 1. Two numbers whose product is 1. You take a number, you multiply it by its reciprocal, the answer is always 1. And our multiplicative property of multiplicative inverse property tells us exactly this, that if you take a number, multiply it by its inverse, which is where you stand that number on its head, turn the fraction upside down if you will, that answer is always equal to 1. And this is what they call the multiplicative inverse property. Big old long hairy names, you just have to understand what they're talking about. Multiplicative, and also be able to identify those properties. The multiplicative inverse property tells us if you take a number and multiply it by its reciprocal, you take a number and you multiply by the multiplicative inverse, which is exactly the same thing, then you don't change the value of that number. So, how are we going to divide rationals? We're going to multiply by the reciprocal. We divide rationals by multiplying by the reciprocal. And what do we do when we're multiplying rational expressions together? We cancel first. We cancel common factors first. So division is just further practice of multiplying rational expressions together. All right, example 4 in your text says we have 4/5 divided by 9/10, I believe. 4/5 divided by 9/10. All right, division is the same thing as multiplying by the reciprocal of the divisor. The number that comes immediately after the division sign is the one that's the divisor. So rather than dividing by 9/10, we are going to multiply by 10 over 9. And now we can cancel common factors before we multiply. And I'm just going to go ahead and take an extra step here and write this out so that it's a little bit cleaner. I didn't need to factor that as 3 times 3. I could have factored this as 2 times 2, which I think I will just to illustrate a point. What pairs of factors do we have in common here? Well, we only have a pair of 5, so we reduce those by canceling them out. We now have 2 times 2 times 2 is 8 over 3 times 3 is 9. That's what you do for example number 4. Example number 5, we have 5/7 divided by 5. Okay, we want to have the reciprocal of 5, but it doesn't look like fraction, does it? Well, whole numbers are rational numbers because you can divide them by 1. Now that's just your reminder that the reciprocal of 5 is 1/5. 5/7 times 1/5. We're going to look and cancel common factors. We have a 5 in the numerator and the denominator, so they go away. And we're left with 1 over 7, or 1/7 is the product of, is the quotient of 5/7 divided by 5. Example number 6, I think. These are in your text. If I've got the wrong number, I'm sorry. I'm going through the exact problems, though, that are in the second edition of Algebra 1 for Christian schools. I believe this is example 6. And this is 2/3 divided by 8/7. 2/3 divided by 8/7. 2, 3, and 7 are prime numbers. If you don't already know this, you'll learn it really quickly that 8 is 2 cubed. It only has a prime factor of 2, and it's used 3 times. 2 times 2 is 4, times 2 times 2 is 8. So we're going to multiply by the reciprocal of 8/7. 7 over 2 times 2 times 2. The only thing that we have in common here is one factor of 2. 7 over 3 times 2 is 6 times 2 is 12. 7, that's interesting. I said 3 times 2 is 6 times 2 is 12, and I wrote 17. The hazards of trying to write and think and talk at the same time. Now, I'm going to take just a tad bit of time on this one. Rational numbers include negative integers in them. So what are we going to do when we have a negative that shows up when we're multiplying something that looks like a fraction? Because I'm fairly certain that you guys did not have fractions with negative signs in them when you were in elementary school. Okay, we have 12/19 divided by negative 5/38. 12/19 divided by a negative 5/38. And just a little tidbit here that will help make things neater for you. It's true that negative 1/7 is the same as negative 1 over 7, which is the same as a 1 over a negative 7. And that has to do with our division rules with signed numbers that you can go back to and look at if you want. But if you don't, trust me when I say negative 1/7, negative 1 over 7, 1 over 7, 1 over negative 7 all have the same value. What will help you when you are working with negative numbers is by always keeping your negative sign in the numerator. Division is the same as multiplying by the exponent. Division is the same as multiplying by the reciprocal. I'm going to keep that negative sign up in the numerator. I'm going to stop smearing my marker. Negative 2 times 19 over 5. You have to make sure you keep a negative number. This is a reciprocal, 38 over 5. I have one factor of 19 in common. 2 times 2 is 4, times 3 is 12, times a negative 2 is a negative 24 fifths. Be very, very careful that you don't lose that negative sign. It doesn't matter if you have your answer, negative 24 divided by 5, or a negative 24, as I write 25. A negative 24 fifths. Same answers. Just be really, really careful when you're multiplying and dividing rational expressions that have negative numbers. Alright, the last thing that I want to do is look directly in your text on page 59. And we're going to review just for a second about multiplying and dividing decimal numbers. We reviewed adding and subtracting decimal numbers in our last lesson, and we remembered that when you add or subtract, you have to line up your decimal points. Well, what do you do when you multiply? let's say that we want to simplify, this is example 8, and we want to simplify 4.28 times 5.31. You notice I said 4.28, 5.31. That's the type of terminology we revert to. This is actually 4 and 28 hundredths, 5 and 31 hundredths, and you see why we say 4.28, because it's much quicker. Well, how are we going to multiply these? We're going to multiply them together just as if they were whole numbers. We're going to ignore our decimal numbers, our decimal points for now, but we're going to make sure that we've got them indicated. And if we multiply, we have 428. We have a 0 here, 3/8 are 24, 8, and I am just not trusting my mind today. 3/8 are 24, 6 is 8, 3 times 4 is 12. Now we're going to multiply by 5. 5 times 8 is 40, carry 4, 21. Make sure 21, 40. Now we add 8, 6, 2, 7, 2, 2. And we end up with 227,268. Now this is why I hate calculators being used too early, because you might think, well, yeah, that makes like, that's reasonable. But look at this, what are we really multiplying? We're multiplying something close to 4 by something close to 5, and 4 times 5 is nowhere close to 227,000. We have to take care of these decimal places. We have 2 places after the decimal point in each of the numbers we're multiplying. So we're going to add those up, 1, 2, 3, 4. And that's 1, 2, 3, 4. That's how many places we need to have after the decimal. And look at this, we have 22.7, which is awful close to the estimate of 4 times 5 is 20. This is all you need to do for multiplying decimals. You add up the total number of decimal places you have, and that gives you the total number of decimal places in your product. Now if you do long division, example 8, example 9, you have to deal with that decimal point as well. 1.26 divided by 0.3. 1.26 divided by 0.3. How do you divide decimal numbers? You look at the divisor, which is the number outside of the house. You move that decimal place as many spaces to the right as is necessary to make it a whole number. 0.3, we move that decimal point 1 space, and we have 3. We've moved the outer decimal point 1 space. We have to move the inner decimal point 1 space also. Carry it up. Now we have 12 divided by 3 is 4. 4 times 3 is 12. We're going to bring down that 6. 3 goes into 6 twice. 2 times 3 is 6, and we have no remainder. So our division is finished, and our answer is 4.2. Look at that in your book. Get on Khan Academy or something if you don't remember how to divide decimal numbers, and just refresh on that, because this is something that you'll want to be excellent at to continue on in Algebra 1. So I believe that's the end, finally, of multiplying and dividing rational numbers. Shoot me a text if you're having difficulty, or ask me about it when we get together on Friday. I'll see you before too long.